Welcome and hello. This is a video tutorial in HEC RAS, and in this lesson, I'm going to be discussing viewing 2D results in RAS Mapper. This is part 2. If you haven't already watched part 1, that's the previous video, lesson 86. This is lesson 87. We have the HEC RAS 2D User's Manual on the screen here, and this particular page I will leave in the description of this video if you want to click the link. Over on the left, there's this menu page if your browser window is wide enough. And what we talked about in part 1 were the first 2 links here. And then what we'll talk about in this video, part 2, will be all the other parts, these subpages from map rendering modes all the way down through 3D perspective plots. For the most part, it will be in order. All right, so let's go ahead and get started. I'll just click on map rendering modes here. What it talks about is 2 different map rendering modes, sort of a horizontal and vertical, or maybe I should say plan view and profile view. And there's an image right here that shows what that plan view distinction looks like, whether you are viewing results that are from a dynamic view or a static view, or I should say a dynamic layer or a static layer. I'm going to go ahead and click on this image here. And what we see here is the extents of the water, or you may call this a flood, over a boundary, which is a gridded cell boundary, where the blue coloring, both light blue and dark blue, represent water. The gray represents the land. And the light blue right here, this represents a dynamic map that is rendered on the fly. And the values are interpolated to sort of create a smooth surface, a smooth boundary between land and water. And then what you see in the royal blue, the darker blue, this is supposed to be the same extent of flooding. Again, we're looking down in a plan view situation. However, these dark blue cells are saved from static maps, and the grid cell is considered either wet or dry, but can't be partially wet or partially dry, like is the case with the dynamically created layers. To go ahead and demonstrate this in RAS Mapper, here are my results. We're looking at this 1K to 21K results. Let me go ahead and turn off the geometry and then turn on just the depth right here. And then I'll click Min. The 3 layers that are automatically created, depth, velocity, and water surface elevation, these are considered the dynamic layers. So what we're going to see is the smooth, continuous boundary between water and land. Now, if I toggle on the 2D flow area, and then what I need to do is zoom in on this particular area. All right, so we have a boundary location between water and land. Now I'm going to quickly generate a static file so we can compare what a dynamic file, dynamic layer here is versus an actual saved file. I'm using the word dynamic file. That's not really true. It's a dynamic layer that's interpolated. It's not actually a saved file. It's just rendering in memory based on the zoom X and Y. Okay, so let's go ahead and create a layer. Right click and create new results map layer. This procedure was discussed in part 1 of the results, so check that out. So I'm just going to go quickly and go hydraulics. I'm going to click on depth and then profile. Let's go ahead and select maybe hour 5 for the heck of it. Now over here, this is going to be the dynamic layer. So these first 2 options here, generated from current view, this would be a dynamic map rendered on the fly. And then down here, stored and saved, this is the static maps. So I'm going to go ahead and just click on raster, a static map, click add to map. It's been added. So I'm going to go ahead and click close. And that's this one right down here. So if I toggle off this one, oh, you know what? I need to actually generate it. So go ahead and right click, compute/update. Give that a minute. All right, so it's been created. I'll click OK. Now here is the jagged edge of the static map that we just created. Now, if I zoom out just a little bit, you notice that the cell extents here is like 100 feet by 100 feet, or maybe it's 200 feet. I could check it, but this cell is partially includes land and water. And you may be thinking, well, why is that the case? I thought this was a static map layer. And it is, however, the discretization is not on the 2D flow area cell size. It's based on the terrain cell size. So let me go ahead and zoom in. So here is the terrain. Hopefully you can see that. Here are the individual cells. And then if I toggle on the depth, this is the minimum depth here. So I have to actually toggle up a few hours. I'll click on depth and then let's see. So this is the first hour, second, third, fourth, fifth, Yeah, so this right here, let me go ahead and change the symbology on the static layer. I'll just call it discrete and then edit. Then I'll just change this to, yeah, royal blue. Okay. And then okay. And then I'll close that. So now I have the dynamic map on top and then the static map on bottom. But if I move the dynamic map to the bottom, so move layers to the bottom, now it's just the opposite. So if I advance the time step for that dynamic layer, here's 6 hour, 7 hour, 8 hour, ninth hour, and so on as the flow and hence water surface elevation continues to increase. Okay, I'm going to go ahead and delete that static layer that I created. So remove layer and delete the source files. Okay. Also, as far as map rendering modes, if we wanted to consider the vertical or what you may see as a profile rendering, we can take a look at that. HEC RAS has 3 rendering modes. So if you go up to the tools menu in HEC RAS and then click options, there's this render mode menu right here. And then the first box is our water surface rendering mode. So our options are sloping, cell centers plus face centers, and then horizontal. So the first option here, the default, this is sort of like hybrid between full sloping water surface and then horizontal water surface. I think it would be easy to explain if I brought up the map. So let me just scroll down to the bottom of this screen here of the page. The horizontal water surface is where each 2D cell has the same constant water surface. So you get sort of a stair step phenomenon. And then the sloping water surface is in the darker blue here. This is where the water surface is interpolated from the each 2D cell face, producing a more continuous water surface elevation, or I should say water depth. This sloping water surface option is probably more appropriate for displaying shallow water inundation depths, specifically in steep terrains. And it also looks a little bit more realistic. All right, so below that, there's a screenshot here that compares the two. On the left, we have sloping, that's A, and then on the B is the horizontal water surface. All right, the third option is a hybrid, which is just sloping but cell centers. This uses the sloping rendering method except for locations where the water is not hydraulically connected. So when two adjacent cells are both wet, but their cell face between them is dry, then this sloping method for cell centers, the hybrid option, uses the horizontal rendering mode for both of those cells. All right, so let's go ahead and click OK. Over to the right, we've already talked about these results layers in part 1, but to add a little bit more detail, I'm going to go ahead and pick on the depth results layer here and talk about some of the items in the context menu, such as layer properties. This is where we can modify the symbology of the depth layer. Let me go ahead and zoom out so we can see that depth layer a little bit more. Okay, right click again. We have edit map parameters. This would basically allow us to modify the parameters of that map. And then after that, we have zoom to layer, add watch to map layers. So this is one I didn't talk about too much in part 1, but if you click that, then down below here, it's kind of minimized. But if I give myself more room, we have this tab that opens up for map layers and the depth is now been selected. I can go ahead and toggle that off. And then let me just turn it back on again. So right click, add watch to map layers. There's the depth. And what's going to happen now is if I hover over the map, I now see the depth. That capital D shows me the depth is 7.62 feet, 7.67 feet, and so on. I can add a watch for multiple layers as well. So if I wanted, say, velocity, I could click on velocity, right click, add watch to this layer as well. And now it shows up down in the table. I have depth, I have velocity. And then when I hover over the water surface, I have a depth value and a velocity value. Keep in mind, this is just for the selected time step. The depth and the velocity and the water surface elevation and all the parameters that I could add to the watch here will be changing in space and in time. Also, you see the values here. Well, there's a column that says no value and then no data, but these no data labels will update with the actual value right now, for instance, as I'm moving my mouse over the layer that actually has some data. Okay, so let's go ahead and remove those, and then I'm going to give myself some more space here. Let's continue on with the depth layer. If I go right click, we now have an option to remove layer, move layer. Those are pretty self-explanatory. Export layer, we can export the layer to a TIFF file, a GeoTIFF file that'll load up into GIS mapping programs. And then we also have this option for export RAS tiles for web mapping. So if I click on that, I can go ahead and give the layer a name. It looks like it just adopted the same name as the plan, so that's fine. And then I need to specify the resolution, which is the cache level. 12 is the highest and 18 is the lowest, or I should say most zoomed out is 12, most zoomed in is 10 or 18, sorry. So whatever I select for my cache level or my zoomed in level, the output resolution and the expected file size values will be updated. So let's see, if I go with 18, this is going to be the most precise with an 5.3 megabyte expected file size, and then the resolution is 1.2 feet. This will export tiles measuring 256 pixels by 256 pixels. That is consistent with Google Mapping. You want to select the resolution that's the highest you want. So if you only need zoom 12, cache level 12, that's what you'll select. But if you needed to get down to zoom level 16, you'll select 16. And then I believe it will also generate 15, 14, 13, and 12. But I don't think it will generate 17 or 18 if you select 16. All right, down below that, you need to specify the profile. So perhaps you only want the maximum for that value, in this case, depth, or minimum, or a specific time range. So I could uncheck those two. Specify the time range. It could be just a single time step, or it could be the entire simulation for all output time steps. An optional checkbox for profile is to click this checkbox if you want to skip steps within that simulation. So if say, for instance, your output data is once a minute, but you only want it once every 5 minutes, then you can just go ahead and click 5 that way. All right. So here is the output file right here. I'm going to go ahead and just say maximum. And then just to make it quick, I'll go ahead and say 12. This is where it's going to save into my project and then inside a directory with that plan name. So I'll go ahead and click create. And it's giving me a message here that says, please only use alphanumeric characters for the layer name. Okay. So I don't think it likes this dash right here, but apparently dashes were fine when I was entering a plan name. So let's see if it creates. Okay, so it looks like it's generating and it looks like it's done. Click close. Let's go ahead and check that out. Here is the project directory. Then if I scroll up, nope, scroll down. Okay, down here is the name of the plan. And then this is the .db file. Looks like it's a database file. It wants to open up in a database application. And I'm not going to do that, but anyway, that's how to export RAS tiles for web mapping. And then the last option here is to view map in 3D viewer. So it's asking me if I want to save my RAS map file and get the latest symbology. The answer is yes. I'm actually going to click cancel just to demonstrate that this same feature can also be opened by this button right here, view results in 3D. So I'll go ahead and click that. Now it's asking me to specify the plan. So I'll click this plan right here and then click OK. And then here's the same warning message I was getting before. So I'll click yes. All right, so it's opening up this RAS 3D viewer menu. And this is the same water surface and terrain that I have. The water you're seeing on the map here is only extends to the upstream boundary condition and downstream boundary condition. I sort of wish I had sketched a longer length of the reach for this particular exercise, but it's okay. When you're in this view, you can zoom in and zoom out using the mouse wheel. And then you can also tilt by using for me, it's the right mouse button. So I'm sort of tilting the map and it's sort of giving a 3D perspective. I can zoom in some more. So here is the river flowing in the westward direction. I can also click on this menu button up here and then click on options. And what it does is it gives me this options menu with the HEC RAS mapper window sort of behind it, where I can modify the symbology or the color ramps of my different layers. For graphics, I can change the screen size. So I actually already did that. It was by default the entire size of my monitor. That was too big for recording. So I changed that, clicked OK. It made me close and reopen the 3D viewer, but that worked out just fine. As well as some other controls here, such as the mouse sensitivity in the X and Y direction, and then particle tracing, which I'll talk about in just a little bit later. But we can show the particles flowing through the map view, but the particle button is right here. Okay. There were a couple parts of this interface that I'll talk about when we get back to RAS Mapper. The one part I did want to mention is, let me close this. I'm going to create a flight plan. So up here in features, back in RAS Mapper, I'm going to go right click on features, create new layer, and then create a flight path layer. So I'll just call this path one, click OK. And then now I'm in edit mode. So if I wanted to do a flight path, say for instance, from here to here to here to here to maybe here, M shape, then I'm going to stop the edits, click yes to save those edits. And then using that 3D viewer, I can go ahead and fly along this path and take a look at the simulation. So let's open up that 3D viewer once again, select the plan, click OK. Yes, save the updates to the .rasmat file. All right, let me go ahead and zoom in now. And then this button here, no, this button here to select the flight path. This is where I can select the flight path. I want to go ahead and click browse. This is the path. It's going to be in project/flight paths. And then this is my only flat path shape file. So I'll click that. There's a few other controls down here, like always look forward or allow for free looking around. I'll do that. And then I want to start from the start of the polyline or the end of the polyline. I'll go ahead and click start. And then now I have some controls here, which allow me to toggle, or I guess that, is it playing? Reset? Well, anyway, the user's manual mentions that it was still in development for version 6.6, which is what I'm using here, but hopefully in later versions it'll be cleaned up. I never actually got this to work when I was preparing for the lesson, but I just wanted to say that there's a helicopter mode and an airplane mode, and you can zoom and tilt and do some other cool things using this 3D viewer. Also, you can play the simulation. All right. All right, well, that was it for part two of viewing results in RAS Mapper. I didn't get to all of the concepts that I wanted to get to, but we'll finish things off in part three.